So the first one, this is a division problem, by the way. But we have to evaluate this like we would the order of operations. And absolute values mean that we need to evaluate them like parentheses. So the absolute value of 6, like we see here, is just 6. Now that then becomes 6 plus 2, all under 24. So yeah, let's write that in, 6 plus 2, all under 24. And we have to evaluate the denominator completely first, if we can anyways. And 6 plus 2 is going to give us that 8 right there. So then we got 24 divided by 8. And 8 goes into 24 exactly 3 times. Next one, we're going to treat those absolute values like we would parentheses, which means we've got to operate on the inside first. Negative 2 times negative 4, that's actually going to end up being positive 8. We'll discuss that in a later time. But then we got the absolute value of 8 plus 9. And the absolute value of 8, well, it's asking how far away is 8 from 0, and it's 8 away from 0. So then we got 8 plus 9. And then 8 plus 9, bam, 17. I'll circle these. Well, the next problem, this one can be a little confusing. 6 minus 6 divided by 3, just because some people still, we struggle with the order of operations sometimes. We got to do the division first on this. So we'll look at 6 divided by 3, which is 2. Then we got 6 minus 2. And 6 minus 2 is 4. So we've taken this thing and we've manipulated it, we've simplified it completely into 4. Yay. Finally, we got this last problem, 30 minus 18. And if you want to use the long subtraction like this, you could. So you'd borrow from the 3 to make that a 2. So you got 10 ones there. 10 minus 8 is 2. 2 minus 1 is 1. So we got final answer 12 right there. Yeah. Alright, now that you guys have the worksheet, go ahead and take a minute and copy down these two objectives. I can add integers and I can subtract integers. So integers, really we're just looking at numbers that do not have decimals, but they can be either positive or negative. And if you can do these two operations with those positives or negatives without decimals or fractions, then you'll be pretty well off and have met the objective. So here's the number line. It's shown. The numbers 0 and 1 are marked on the line, as are two other numbers, A and B. Now we don't know the exact value of A or B. I suppose we could find it out, but it doesn't really matter. It says, which of the following numbers is negative? Also, choose all that apply. Explain your reasoning, which we will do verbally. So on this one where it says A minus 1, then I would have to take this value of 1, and I would have to move to the left in that direction that far from A. Alright, now I can see that this is where I end right there, which is still to the right of 0, so this A minus 1 stuff, just based on the values he gave us on the number line, is going to show a positive number. So this is not one that would give us a negative. However, A minus 2, right? Well, that's a whole different story. Alright, so let's look, see how far 1 is, right? So there's 1 right there. And I'm actually going to move it this far again and kind of copy it over like this, okay? So now that I have that, I can get rid of this garbage. And so the length of this purple line here is 2. I'm going to take it away from A, right? So I got to move to the left from A. And now you can see it puts me just to the left of 0, which is in the negatives. So this is in the negatives. So B would give us a negative value right there. Now a little bit about negatives, especially when we see a negative letter like this or a variable. That would be considered the opposite of B. Now B right now is over here. There is B. And how far away is it from 0? It's about that far, you guys. So what I want is the opposite of B, so I'm going to go in the other direction of 0 with that right there. It's not supposed to move that, but we'll talk about it, okay? Well, that put us in the positives right there. That's in the positives. So this one is also going to give us positives right up and down. Next up, we got A plus B. So, A plus B, right? and A is this long. Now B is this long from 0, right? So if I were to go back, let me take that back actually, make this work. So B is this far away. If I combined the two from A, we can see that B is farther to the left than A. Let me rephrase that. B is farther to the left from 0 than A is farther to the right, is far to the right from 0, which also puts us in the negatives. So this one also negatives. Bam. All right, well, A minus B, that's really asking what's the difference between A and B, which also is a distance. Now, some distances could be negative, especially when you talk about pure mathematics, but how far away is A from B? Well, from B, you'd have to go this far to get to 0, and then you'd have to go this far again to the right to get to A, which means we're always traveling in the positive direction, which means this is actually end up being positive. And there are more reasons for it than that, and we'll talk about those later. But for now, just understand that A minus B is positive for now. All right, so that was a negative B, right? Well, B is, if this will start working, if B is this far away from 0 to the left, well, the opposite would be this far to the right from 0. Well, about that, I tried. So this in red would be considered negative. The negative in this case is describing an opposite. And B right now we know is negative because it's to the left of 0. So the opposite of the negative would be then its positive value. B is a bigger negative than A is a positive. So even though some of the parts of B would cancel A, and this is for part D, right? You'd have more negatives than positives, which means that the sum total is still going to give you a negative answer on that. So part E, you could say, well, subtraction is like getting rid of stuff, right? So if you're getting rid of negatives, it's the same thing as adding to your total, which again, we'll talk about. Well, you may have learned some rules for doing arithmetic with positive and negative numbers. Many people find these rules hard to remember and don't understand where the rules come from. Now, the following mythical story provides a context for understanding how positive and negative numbers work. Many people find it easy to remember the story many years after they first heard it, and the memory of the story enables them to reconstruct the rules. The story has also helped some people make sense of the rules. Here is the story. In a far-off place, there was once a team of amazing chefs who cooked up the most marvelous food ever imagined. They prepared their meals over a huge cauldron, and their work was very delicate and complex. During the cooking process, they frequently had to change the temperature of the cauldron in order to bring out the flavors and cook the food to perfection. They adjusted the temperature of the cooking either by adding special hot cubes or cold cubes to the cauldron, or by removing some of the hot or cold cubes that were already in the cauldron. The cold cubes were similar to ice cubes, except they didn't melt. And the hot cubes were similar to charcoal briquettes, except they didn't lose their heat. If the number of cold cubes in the cauldron was the same as the number of hot cubes, the temperature of the cauldron was 0 degrees on their temperature scale. Now let me demonstrate that for you, right? So we'll say red is hot, and I'll use purple for cold. So that's supposed to be a cube, by the way. So if in the cauldron they had this red cube, and then they put in this purple cube, would say that the red one is hot, which we could show with a positive symbol, and the cold one is cold, which we could show with a negative symbol. And if this was what was in the pot, then you would have a total temperature of 0 degrees. Okay? Now that's true for any number of hot and cold cubes. Like if there's 2 hot ones, then there'd have to be 2 cold ones to get a total temperature of 0 degrees. Now on the other hand, if let's say there was more, we'll say there was more colds than hots, right? Like this one right here. Well, now it's not 0 degrees. Now you have more colds than hots in this thing, and you have one more cold than hot. So now the temperature would read as -1 degree. I am just going to say that they're 1 for now. But yeah, we could use these like bigger ones, right? Bigger cubes to represent 10 and 100 or 15 or whatever you want. So let's change the situation a little bit. We'll look at other examples, you guys. But let's say that there were something like this, right? So now we're saying that there's, again, for me, they're all representing 1 degree. But now, this isn't 1 degree anymore. Let's say, well, we got 5 of these hot cubes, and we got 3 of the cold cubes, so it's no longer negative 1 degree, right? Let's say, well, now there's 2 extra hot cubes in there, so now it's a positive. If you want to show the positive, that's fine. It's just most mathematicians are lazy enough they don't. But you're welcome to if you'd like, okay? But yeah, this would read, this particular example, if this was what was in the cauldron, would read as positive 2 degrees. For each hot cube that was put into the cauldron, the temperature went up 1 degree. For each hot cube removed, the temperature went down 1 degree. And hopefully that makes sense too, you guys, as we take hot cubes out, it also removes temperature from the cauldron. Similarly, each cold cube put in lowered the temperature 1 degree, but if you take cold cubes out, it raises the temperature. So the chefs used positive and negative numbers to keep track of the changes that they were making to the temperature. For example, suppose 4 hot cubes and 10 cold cubes were dumped into the cauldron. Assuming it starts at 0, then the temperature would be lowered by 6 degrees. Well, even if it wasn't, you'd have a decrease of 6 degrees altogether. Since 4 of the 10 cold cubes would balance out the 4 hot cubes, leaving 6 cold cubes to lower the temperature 6 degrees. The chefs would write positive 4 plus negative 10 equals negative 6 to represent these actions and their overall result. Similarly, if they added 3 hot cubes and then removed 2 cold cubes, the combined result would be to raise the temperature 5 degrees. In that case, they would write positive 3 minus negative 2 equals positive 5. Because they took out cold cubes, you guys. And if they wrote negative 5 minus positive 6 equals negative 11, it would mean that they took out 6 positive cubes, which again would decrease the temperature. So it would mean that the first 5 cold cubes were added and then 6 hot cubes were removed, and that the combined result was to lower the temperature 11 degrees. Yes, as you put cubes in, you're adding those, even if it's negatives, and as you take cubes out, you're subtracting because we're removing those out of the cauldron. Number 1, each of the problems below describe an action by the chefs. Figure out how the temperature would change overall in each of these situations and write an equation to describe the action and the overall result. Part A, 3 cold cubes were added and 5 hot cubes were added. Part B, 5 hot cubes were added and 4 cold cubes were removed. Part C, 6 hot cubes were added and then 4 cold cubes were added. And finally 3 hot cubes were removed. And part D, 4 cold cubes were added, then 10 hot cubes were added, and finally 3 cold cubes were removed. Take a minute with your neighbor and see if you can figure out how to write these as a math expression and figure out the overall result. 1 minute, go! All right, let's go over these. So on this first one, it says 3 cold cubes were added. Now, since they're cold, we'd show them as negative 3. And then 5 hot cubes were added, so we're going to add to that. I guess I'm using the backwards color on this, but I don't really need to show the positive sign. You're welcome to, though. Now, by doing this, and we could show this with a diagram, right? I'll go back to I'll just use the colors I'm using. Dang it. 1, 2, 3 negatives, and then 5 positives, right? So if we added this to the cauldron, or whatever the crap this is, well, that'd be a 0, that'd be a 0, that's a 0, right? They essentially cancel each other out. And what are we left with? Left with these 2 positives. So the final change in degrees would be a positive 2. And again, you don't have to show the positive sign, because I'm not really going to do that very often, okay? Definitely not for positives. So next up, 5 hot cubes. I'll go back and use the actual correct on this one, the colors. 5 hot cubes were added. 1, 2, 3, 4, 5 hot cubes. And then 4 cold cubes were removed, right? So if I took these 4 cold cubes right here, right now I have a total change of, well, 1, right? I'd have positive 1, but as soon as I wipe these out, then what did I do? It's the same as taking those 4 out, which is the same as adding the 4, right? Which shows a change in temperature of 9 degrees. So part C, 6 hot cubes were added. So I'll just write this in. We got, well, I guess I need some space, don't I? I apologize. I'll show that in part B. So it starts out with 5 hot cubes added, and then 4 cold cubes removed. Since it's being removed, we show it as subtraction of the 4 negatives like this. So we're subtracting negatives, which again is the same thing as adding positives. So part C, right? 6 hot cubes were added. So we'll show this as positive 6. Then 4 cold cubes were added. So that's added with 4 cold cubes. We'll show this as plus negative 4. And then finally 3 hot cubes were removed. Since they're being removed, we're going to subtract. And again, I'm showing this as positive 3, right? Well, by adding those 4 negatives right there, the total between these two would have been positive 2. But then we still need to take out 3 positives out of this. That was positive 2, by the way. And by doing that, I end up with negative 1 degree in change. So part C would show a negative 1 degree change between those 3 actions with the cauldron. Finally, part D, 4 cold cubes were added. So cold cubes, that's negative 4 right there. Then 10 hot cubes were added. So we're going to add 10 hot cubes. And finally, 3 cold cubes were removed. So they're being removed, so we're subtracting that. And they are cold cubes, so we're going to show that as minus negative 3. Now, like I've said, and I'm actually going to change this a little bit. By subtracting negatives, we're actually adding to the temperature on that. So I'm just going to show it as plus right there, you guys. And then, by combining these 4 negatives with those 10 positives, would end up with 6 positives. And then add those 3 together, and you'd end up with a 9 degree change right there as well. So as of right now, I'm just putting the negatives kind of up top so we can see the difference between the negative and the minus sign. Eventually we'll figure out how they're related as well. But for now, yeah, I want to notice the difference between them. Let's work this a little backwards. Describe the action involving hot or cold cubes that is represented by each of the following arithmetic expressions and state the final overall effect on the temperature. You guys take 1 minute and do this as well. 1 minute, go! Alright, so the first one shows if you got 4 hot cubes added to the cauldron, or whatever you want to say. So 4 hot cubes added, and then you removed 3 cold cubes, right? Now the overall change in this is going to be 7 positive, well, positive 7 degrees. 7 degrees. You don't really even have to put the degrees on there. But whatever, 7. Positive 7. Now the next one, it's 6 cold cubes added to 4 cold cubes. And this would give us a net result of negative 10 degrees. Part C, it's got 4 cold cubes added and then 6 hot cubes taken out. Now again, it doesn't show the positive for that 6, but it is there. It's because we're taking away those 6 positives. So again, this would show a net result of negative 10 also. Part D, we've got 3 hot cubes added, and then we're adding 7 cold cubes as well. This is going to result in 4 negative degrees. And then finally, 12 cold cubes added and 5 hot cubes added would give us a net result of negative 7. So that would have dropped the temperature by 7 degrees right there. So this is kind of like hot and cold cubes. It's just some are shaded in and some aren't. Just understand that what we're seeing on here is showing that the shaded ones are actually negatives, negative ones, and then the not shaded ones in are positive ones. So again, this goes back to the hot and cold cubes though. I mean, if you'd rather think about it like that, that's fine. where a hot cube and a cold cube have a net effect of 0. So I mean, I put a 0 right there, and then this one would be 0, so part A would have a final effect of adding 1 right there. Now it says write the expression. Let's go and do that as well. It's the same thing as 2 plus I'm sorry, that's 3. It should be 3. Because it was positive 3 squares, and then we're going to add 2 negative squares. Now, if you'd like, you can put negatives in parentheses like this, which may help you to understand the difference between the negative and the plus sign. Otherwise, without those parentheses, it may read as 3 plus minus 2, which sounds weird. When we talk about the signs of values, we want to use the specific wording of negative on that, okay? Now, this next one would show, and you don't have to start with the positives, I just do because I can. We got 2 positives, and then we're going to add those 3 negatives. So I'll use, again, parentheses to show that. And then, again, these are going to zero out those 2 positives with those 2 negatives. And then we end up with net result of a negative 1 right there. Now, part C, this is a positive with a negative, which means it results in 0. And, yeah, you could have just written that as 1 plus a negative 1 if you'd like. And this, as it turns out, is the additive inverse, which is a huge deal, the additive inverse. When you add the inverse of something, it's really just the opposite. Then you get 0. I'll write that in. So let me show you guys a different example of that. Over here, I'll make this as an example. So we could take any number, big or small, partial or not. I'm just going to use whole values, though, like, let's say negative 9. Well, the opposite of negative 9 is positive 9, and if we add those together, we get 0. It's that simple. And again, this property is crucial. We're going to be seeing a lot of this property in, I think, the 3rd unit. Maybe it's the 4th. Number lines can also be used to model adding and subtracting integers. Use the number line below to model the football team that moves the ball forward 9 yards on one play, then loses 7 yards on the next play. Then write an equation to represent the situation. Let's do this one together. So, on this one, it shows that they gained 9 yards, right? They went forward 9 yards. Now, we're just going to start them at 0. I know some of you guys would be like, well, they start at 10, right? Well, yeah, they got 10 yards to go, but this one shows that they're going to go forward 9 yards, so that would be right here. And then they'd go back 7 yards, 1, 2, 3, 4, 5, 6, 7, right there. And where are they at now? Well, they're 2 yards forward from where they started at. So the equation on this one would be, yeah, they started with 9 yards. And then they went back 7 yards, so you could write it as minus 7. But since it was a loss of 7, you could also write it as 9 plus negative 7, if you'd like. Now, this concept as well is quite crucial, because if you guys hate seeing minus signs, you could rewrite it as adding negatives. It's the same exact thing. Or, if you don't like seeing plus negatives, you could actually change it always to just simple subtraction on that stuff. I use the number lines given to solve each problem. So again, and by the way, I don't always start at 0 on these. So I would say, like part A, it's like, dude, just start at 4. And then it says adding 3. Well, to the right is the adding direction, and it's positive 3, so you go 1, 2, 3 to the right, and you end at 7 right there, okay? Now part B, where it's negative 6, again, that's where I would start, right here, negative 6. And then it says plus negative 4. Now, the thing about plus is it's to the right, but it's a negative. So I'm actually going in the opposite direction of plus, which is to the left. 1, 2, 3, 4, and I end up at negative 10. So this one ends up being negative 10. Now, for a lot of students, that's confusing. So if you hated that, just ignore the crap out of it, okay? It's not required that you use number lines. It won't be required on the test either, which isn't for a couple weeks. And then finally, 3 plus negative 7. Again, you start at 3. You're adding a negative, so it's like, dude, if you wanted to just show it as minus 7, you could. And then you'd know that you're just going to go in the minus direction, which is to the left. 7 spaces, 1, 2, 3, 4, 5, 6, 7. And you end at negative 4. Okay? So a few different ways to look at that. If it's not registering, if none of that's registering, then the pure math also works. Alright, so just like I was showing you guys, when you have a subtraction expression, it is possible to rewrite it as an addition expression. Same with an addition expression. If you have an addition expression, you could rewrite it as a subtraction expression. So take a moment and see if you can actually figure that out, to change these subtraction problems into addition, and actually find the answer to these. Or change addition to subtraction, okay? We'll give you guys 1 minute to work with the neighbor on that. Go! Alright, here's the stuff for you guys to check your work. Remember, if you're subtracting a positive, it's the same thing as adding a negative. Or if you're subtracting a negative, it's the same thing as adding a positive. Or, I think I said that one, but yeah, adding a negative is the same thing as straight subtraction or subtracting a positive. Same thing. Now, just so you guys understand the difference between these two, and I usually do this when I'm doing work with integers like this, like that -10 minus -7. Whenever I see that, if I were to see this problem straight up, I would actually just cover it with a plus sign like that. Which is, you can, because it is the same thing as adding a positive. Alright, so how do you decide if that symbol means subtract or negative in numeric expression, and how can we use a number line to show subtraction? Well, it all depends on context, you guys. So if it is subtraction, it'd be straight up in the expression. It's not usually in between numbers where you'd say 5, -7 or something like that, okay? It will show as an operation. Subtraction is an operation. Whereas the negative is only relating to the individual term or a single number, okay? So a negative tells us the sign. But as we've seen, it is possible when you add negatives to convert that sign into the operation of subtraction as well. So how could we use a number line to show subtraction? Well, subtraction is to the left of the number line. But subtracting negatives is actually going to the right on the number line. So we have to be careful. Negatives will tell us it's in the opposite direction. So use the number lines given to show shown. Use line given or shown, I guess. How to solve each problem. Show how to solve each problem. Okay, that makes sense. So again, you always start with the first number. So like on this one, we'll say, well, we're going to start at -4. And since it's -6, the minus direction is to the left, so we're going to go to the left 6 units. 1, 2, 3, 4, 5, 6. And we see we end at -10 on that. Alright? The next one, this starts at +3, but then, again, it's going to the left 7 because it's -7. And minus is to the left direction. So we're going to go to left 7. 1, 2, 3, 4, 5, 6, 7. And we end at -4 right there. Same with part C, we start at 4. Now this one is like taking away 3 cold cubes, or taking away 3 negatives, which means, as it turns out, we could write it as just +3, and plus is to the right, three spaces right there, so we end at 7 on that one, +7. Again, and it's a good question. You don't have to show it exactly like this. You know, some students would just be like, there's 6, and there's 7, and it goes to the left, or there's 3, and it goes to the right. You can do that if you'd like. Alright, write an equation to represent each situation. So you ride your bike 12 miles and then get a flat tire. You turn around and walk the bike 4 miles before your mom is able to pick you up. How far are you from your house when your mom picks you up? So the expression right here, you're going to ride 12 miles out from your house. And then you get the flat tire, so you're going to walk 4 miles, but it's in the backwards direction. So you could put -4, you could put plus -4 if you'd like. But the result will be the same. How far away from your house when your mom picks you up? That'd be 8 miles right there. Alright. Next up, part B. Zach's football team moves the football 35 yards forward on the first down. On the next down, they lose 12 yards. On the down after that, they go forward 8 yards. How many yards total from the starting point did they move the football? Well, again, so they're going to start with the 35 yards right there. That's positive because they went forward. And then they're going to lose 12 yards So for loss of 12, I'm just going to show as minus 12 right there. And then finally, they'd go 8 yards forward from that point. So plus 8 right there. All right. Now I would evaluate this 35, and then minus 12 would be a difference of 23 yards. And then finally, then add the 8 on that would be a change of 31 yards. And again, we'll describe this. It's forward from where they started. Then part C, an osprey flies off the ground and reaches 35 feet above the river. When he sees a trout, he then dives 37 feet down to get the trout. How many feet below the water does he end up? Well, again, he's going to fly 35 feet above the ground. And then he's going to dive down 37 feet. So he's going to down, that's a minus right there. And as he goes down, he's going to end up 2 feet below the surface of the water, which means it ends up being a -2, which show it as -2 feet. But if you were to describe it as just 2 feet below, you wouldn't need the negative. You wouldn't say -2 feet below. Then it's redundant and could be interpreted as a double negative, which is not what we want, okay? Summarize how to add and subtract integers by writing some. I found some. There they are. Is this all of them? I would say no. But there are some rules. There's some rules if you like them. All right, hopefully you guys feel good about the objectives. I can add integers, and I can subtract integers, whether they're positive or negative. Hopefully you guys have some good rules down so that you guys can do those very well.